Hello guys, so in this video I want to talk about the virtual destructors in C++. Um, so we'll look at a couple of scenarios so that we can nail the point. So what does a destructor do in this case? So destructor takes care of if memory is allocated and you know the function um, you come to the end of the function or you're not using that function anymore, um, it would clean up the memory, right? Release back that memory. So if there is no virtual destructor, or if there is no destructor, then you can have some memory leak because you will have memory that should have been cleaned up just hanging around. All right. Okay. So in this code here, I have a base class and have a virtual destructor in the base class, and I have a derived class feeding up that base class. And here we have a base pointer to the base class, which is managing a derived class object. All right, and then we are calling the function that is present in the base class and the derived class as a override function or a virtual function, right? Now in this case, if you run this code here, we are concerned in this video to see how the destructor operates. All right, so we just want to see what happens in this case here. So in this case, if you run this program, I already had these things compiled, so I should be able to do this. Virtual destructor, virtual des. Okay, so we have the derived class function called and the derived class destructor. All right, so we didn't have anything with the base class function here, so let's look at this a little. This is called and this is called. Nothing from here is called. All right, that's one scenario. Now let's go to scenario 2. In this scenario, we have the virtual. In the first scenario, we had this as default, so that means that the derived class would have inherited this virtual nature here. Now in this scenario, we are doing pretty much the same thing, but we don't have a default. So if you run this code here now, let's see, virtual ds2. So we have the derived class function, right? We have the derived class destructor, and then we go back to the base class destructor. So let's just look at this here. So your steps when you call the function, when you run this code here, ptr show, it will call this function. It will not call this function because this is virtual and we are dealing with a derived object here. So ptr would call this function. You would have this here, then it calls the destructor in the derived class. So you have derived function, derived class destructor, then so 1, 2, 3 in that order. Okay, so then it calls a base class destructor. Now what the object is a derived class object. What's the point of calling the base class destructor? So in any scenario, you have a component here would belong to the base class. When you call the base class destructor, it's taking care of any memory allocation or anything to do with the base class. It's taking care of that, so freeing up that memory. Now let's look at the third scenario here. So in this scenario, I have a non-virtual destructor in the base class, and I want to see what's going to happen. And I have a virtual function here show. So I'm inheriting, and I think I need to recompile this code. So let's do that right now. So g++ std c++ 2a dash o. This is gonna be virtual ds3 and virtual ds3 dot cpp. So give it a minute. Okay, so now we can run this virtual ds3. So what happens in this case? In this case, we have the derived class function called, but we don't have the keyword virtual here. So although we are doing inheritance here, you see that you have this call and then followed by this. It omitted the destructor in the derived class. Now this is a problem. This can lead to memory leaks and lingering like memory blocks, right? Because if you're not calling the destructor in this class here, it's going to create problems for your program, right? So that is the importance of the destructor. So you can pause here and read. So you see, if the base class destructor is not declared as virtual, deleting a derived class object through a base class pointer will result in only the base class destructor being called, which we saw, and the derived class destructor not being invoked, leading to resource leaks or incomplete cleanup. This happens because without the virtual keyword, the destructor call is resolved statically based on the type of pointer and not the actual object type. So a virtual destructor ensures proper polymorphic behavior. Alright? When a base class pointer deletes a derived class object, the derived class destructor is called first, followed by the base class. So that would be the standard process. So always use a virtual destructor in a base class intended for polymorphic use to avoid resource leaks and undefined behavior. Now on this note, I wanted to show one more scenario in this video here. I hope I can do justice to this. So I want to show you this. Now let's examine something here. See here, I have the base class and the derived class, and I'm concerned with this here, this one line. What it means is that you have a pointer to a base class and it's managing a derived class object. So it's like you have this, let's say this is a pointer ptr, and this derived class could have, let's say this part is the base class part, right? And this it's non-base part of derived class object. So this pointer here, this PTR, is pointing to this portion here. Let me try to code this so you get an idea. It's gonna deal with this. So anything that you inherit from the base class, for example, here there's this function show function, and there's a show here. This pointer, you can use this pointer to get to that function, but you cannot use this pointer to get to this non-specific function or this specific function within the derived class. You see, you'll get a compilation error here. But there is a way around that to you can use dynamic cast and cast the derived pointer. You know, you can create the actual pointer to become a derived pointer and then access that memory or this function here. But the idea is just to explain this line, to say that this line is saying you have an object. This is the object. It's from the is a derived class object. Part of this object here is the base class plus any inherited functions or variables, whatever, from the base class. The non-base part, this pointer here cannot access. Okay, so I am just tying in this here because there is virtual here, and you can actually run this function here, but you cannot run this function here because you don't have a virtual of specific function in the base class. So, and you cannot use the same pointer to do that. So that is all I want to capture in this video. I'll stop here for now, guys. Bye.